Alrighty, to wrap up understanding limits graphically and numerically, we're going to look at example 4. And it says, you own it. In this box below, complete the sentence in your own words. In order for the general limit to exist, the function, and then let me know, and be ready to discuss this tomorrow in class. We will compare each other's definitions. Example 5, sketch a graph to satisfy each set of conditions. All right, so we're going to look here. F of A is undefined. X equals A is a point discontinuity. The limit of f of x as x approaches A exists. So there we go. So let's do a graph. So let's be f of x, which is just your fancy y. This is going to be x. All right, so it says A is undefined. So here's my A. So for the undefined, that means there's some type of hole there, like it's not actually equal to. X equals A is a point of discontinuity. So that just means that it must be doing, like this is a gap. So that means there is no other point on A. It doesn't jump. Limit of f of x A exists. So that exists, that means from the left and from the right must be coming from the same direction. So there you go. And you can make it as fancy as you want it to. All right, over here, let's do the same thing. Let's make a graph. Limit of f of x as x approaches A does not exist. All right, so that means if this is my A, does not exist, that means I'm going to have open circle here going this way, maybe an open circle here going this way as well. But it does not exist because it's two different spots. X equals A is a jump discontinuity. So that does mean that one of these does have to be filled. So the third one says f of A is defined, so this has to be one of them. Make it this one. So it jumps up to here and goes that way. Actually, it's filled in right there. So anything like this satisfies all those. All right, so last question. So example 6, finding limits from a table of values. So now consider this function here. Complete the table below to find the limit as x approaches 3. So this is how you do it numerically. So what you're going to do is on your calculator, you can go to new document. I don't want to say none of this. I want to add a graph. I'm going to type that equation in. So control divide. That's going to be x minus 3 over x squared plus 2x minus 15. I'm just going to hit enter. All right? So if I do now menu, trace, so 5, graph trace, so 1, and I can just hit the value. So for instance, we are looking at 2.9, so I'm going to type 2.9 and hit enter, and I actually get the value. So 0.127. All right. And then if we do 2.99, you'll see it says 0.125. All right, so the next one, let's do 2.999. Still 0.125. All right, so let's do 3. We see it's undefined, so it does not exist at that point. So then let's do 3.001, 0.125, and 3.01. All right. So that's going to be 0.125. The next one will be 3.1, which would be 0.123. So if we look at this right here based on our analysis, what are the values of each of the limits below? The limit of f of x as x approaches 3 from the left side, we can easily say that it's going to be 0.125. We say from the right side, we can also say it's going to be 0.125. And then since both of those are equal, we can officially say it is 0.125. And again, this is numerically not the ideal way to do it, but it's definitely a way. All right. This concludes. Don't forget to post in the discussion a question or comment on what you learned in this unit or section.